In previous tutorials, we demonstrated how to connect to the SWAPI API, and we got the data freely. You might wonder, what about other APIs? Do I get data from other APIs for free as well? Real APIs, especially those providing up-to-date, time-sensitive data, are charged by usage and require some sort of authentication in order to use them. Before diving into coding, it is important to first read its API document. To understand the API function, URL required parameters, expected response, authentication method, and, of course, how it is charged. In this video, we look at the simple case of OpenWeather API, a type that takes query string parameters. There will be 3 parts to this video. First, we will quickly go over the basics of OpenWeather API documentation, followed by the review of the example EB Pro project and the JavaScript codes. At the end, there will be a demo EB Pro simulation of the OpenWeather API call. This is the main screen of our example project. Our goal is to make an API call where we enter a city name and get its current weather conditions. OpenWeather has an API that exactly does this, and we can find out everything about this API in the documentation. Looking at the API call requirement, it appears that it will be one with query string parameters. 2 parameters are required: Q, the city name, and an app ID. App ID is required for authentication. As for the optional parameters, mode, if we leave it out, we get JSON by default, which is what we want. We'll leave out language parameter as well, and we should expect English as the result. As for units, let's use this parameter to make sure we get metric result. To get the API key, first sign up for an account and then generate an API key in the key management page. At this point, we have a clear idea what we will be sending. Next, we should figure out what API response we will get. Back to the API documentation, JSON example of API response is here. Let's say we are interested in the current temperature, humidity, and description of weather conditions. So here we take note of their locations in the JSON data structure. Now that we have all we need, we can go to EB Pro to start making our project. On the main screen, there's an ASCII input field for the query city name, numeric and ASCII display fields for showing the results, and a GetWeather.js object button, which executes JavaScript codes when it is clicked. For the JS object, corresponding input and output addresses are set. For simplicity's sake, constants like URL and app ID are hard-coded in the source code. Now let's review the source code. The first few lines allows the JS object to respond to a click action, making it a clickable button. When it is clicked, it executes the update function that follows. The update function first, by calling another helper function, retrieves the city name input from user and then sends out the request. In the case of OpenWeather API call, query string parameters are used. In using the request .get method, instead of having to construct the entire URL by yourself, simply include a data object with all the parameters. The complete URL, including the query string parameters, will be automatically generated. Shortly after, the callback function containing the response data is called. Earlier, we figured out the location of the data we want, so here just parse it accordingly and use suitable driver methods to write the data to the HMI memory. The last part of the source code is the function that reads user input of city name from the HMI memory and then do the binary to string conversion. Why this conversion is necessary was discussed in the previous tutorial. Finally, let's watch our project go into action. First, I enter a city name and then click the Get Weather button. Let's try another one. In this tutorial, using OpenWeather API as an example, we showed how to make an API call with query string parameters with JS object. Thank you for watching.